Here we're going to explore the connection between radian measure, arc length, and central angle. Now, these connections all stem from the following equation, that theta, the angle measured in radians, is equal to the arc length divided by the radius. Okay? So what's important here is that the angle is in radians, so this is the radian measure of an angle, not degrees, but radians. And another important feature is that the arc length and the radius have the same units. So S and R have the same units. Okay, and these units could be miles, miles and miles, and feet, whatever, whatever it is, whatever they are, they just have to be the same. And of course, this is a diagram of those three quantities. Here's the angle. Now the measurement of the angle is in radians. And S is the arc length, that's the length of this arc, and R is the radius of the length of the radius of the circle. And those three quantities are related by this equation. Now it turns out that, of course, if you have 2 out of the 3, you can find the 3 arithmetically, and let's see how to do that now. So find the length of the arc. Okay, so we're looking for arc length, S, of a circle of radius 13 inches intercepted by a central angle 120 degrees. And so right away I note that, okay, we're given the radius. Let's write that down. R is 13 inches. And we're also given the angle, right? The angle theta is 120 degrees. Now you have to be a little bit careful because we want to make use of the equation theta is always equal to the arc length divided by the radius. But remember, when you use this equation, theta is measured in radians, and right now our angle is measured in degrees. So what we want to do is first convert this angle to radians so we can make use of it right here in this equation. So to do that, remember there are 180 degrees for pi radians, and set that equal to the measurement of the angle in degrees divided by the number of radians in that number of degrees. And we have to solve this equation for x. So it's going to be 180x is equal to 120 times pi. Divide both sides now by 180. And let's see, we get x is equal to, well, the zeros cancel and we get 2/3 pi. Now what that means is that 120 degrees is the same angle as an angle that's 2/3 pi radians. And that's important because then we can take that 2/3 pi and replace theta with it. So let's do that. So the angle theta in radians is 2/3 pi. And the arc length, of course, the S, that's what we're looking for, right? Find the length of the arc. So we'll leave that just as S. Let's try that again. So it's going to be S divided by the radius, which is 13 inches. And we'll just write 13 for a moment. So we have to solve this equation for S. So we'll do that by multiplying both sides by 13. Let's write 13 over 1. So I get 26 over 3 times pi is equal to S. Now remember, the arc length and the radius have the same units. Now R is in inches, right? So that means the arc length is in inches as well. So our answer is this. The arc length is equal to 26 over 3 times pi inches. It's a measure, it's a length, arc length. Okay, let's try another one like that. Find the radian measure of the angle theta, where the arc length is 90 miles and the radius is 30 miles. So remember, these two have to have the same units, and they do, right? Both are in miles. So if we had a problem where one was in feet and the other one was in miles, we'd have to make sure they were both in feet or convert them both to miles, just as long as they're the same. But since they are the same, we can jump right to the equation. The measure of the angle in radians is the arc length divided by the radius. So theta in this case is equal to 90 miles divided by the radius, which is 30 miles. That's a big circle. And then the miles cancel, right? The units cancel out, and you get theta is equal to 3. Now 3 what? Radians. What's the meaning of that word radians? Well, it's basically telling you that 3 radii fit into that arc length. So we have an arc length that's 90 miles long, and clearly 3 radii would fit into that arc length. That's all a radian is doing, is measuring how many little radii would fit into that arc length, okay? And once you have that number, this is a dimensionless number. What you do is you say, okay, it's that number of we don't say radiuses, we just say radians, indicating the number of radii fitting into that arc length. Okay, and that's it. Until next time.